let's continue. So next part is we're going to build aarch Linux GNU, which is compile ARM64 programs on Windows. Let me see what the micro is set up. Okay, no problem. It's just set up, right? It should be sound. Choose your sound input device, right? It's set up. So let's just do it again. Okay. So now we need to ensure these two Trojans are all in the list here. Okay. Right, we have these two Trojans. Now we're gonna start cross compilation, right? Canadian compilation. We need to ensure we have these two Trojans, and we're gonna compile the ARM programs. We're gonna finally can be able to produce binaries on Windows, provided then that the binary will running on ARM64 Linux GNU machine, which run the Raspberry Pi. So we're still going to do is bin utils, right? Now first, just like we did before, okay, we need to just git pull bin utils here. Then what we're going to do is that we're going to just do this, right? Just like we did before. Enable Go, right? Go linker. We also need Go linker because the target is on the ELF. In the ELF, we always need Go, right? We probably want Go linker. aarch64 Linux GNU. Then we're gonna just do host. Host is x86 min GW32, right? Now you can just start to check whether all the Trojans exist. It said yes, all the things exist, right? So we need, so now Gdbc is using three Trojans, using the bin utils using three Trojans, one using our build system, which is G++, and x64 W64 min GW32, and aarch64 Linux GNU, three Trojans to build our things here. I'm not going to start many threads, just three with Gdbc, okay. So now we're going to do one thing is that we need to just install all the Linux kernel header files and the things that we just did before to our cross compiler, right? To the new cross compiler we have here. Wait. I think I forgot one thing is that we probably not say prefix, right? Yeah, we did not say prefix. So prefix is now in the Trojans x86 min GW, which is host, right? Trojans GNU is not in LVM, it's in GNU. Then put aarch64 Linux GNU, right? It should be here. Okay. Oh no, not here. Don't put too many threads. Less. Now what we're gonna do is that we're gonna install all the headers from Linux kernel. Okay, we're gonna install headers and libc. The libc we just built, put them together. Assemble them. We just do assemble them. We still do make headers. Install aarch here because ARM34 install HDR parts equals home Trojans GNU aarch64 Linux x86-64, which platform it hosts, then which platform it builds, right? We put that. But we cannot just directly put that, we need to put another subdirectory. Okay, we now install here. Now we're gonna install the Gdbc inside here. Let the build things and we just copy the Gdbc we just built last time if you haven't watched that, you should watch the last video. And we're gonna put the des. We just put the des here, right? With the des, I should be able to just manually migrate to other directory. It's quite a mess with when you have all sorts of build host target, right? So we have all the libraries installed here. GMP, whatever. I don't want to deal with GMP. Let's just go to lib. We need to copy, include, and lib to the thing we're running here. We don't need to. If you want, you can also copy whatever, but it won't be able to run on Windows. Okay. If you want to just do it again, you can just compile Gdbc again and put Gdbc inside the torch. It also works. But I'm not going to waste time on build that thing again. So what we're going to do is that we copy all the lib, entire lib directory to the Canadian compiler, Canadian cross compiler. GNU, right? Should be x86, which means we are the host and we are targeting. GNU, aarch64 Linux, GNU, right? Omitting directory, we need to put a R here, right? Now I'm going to copy include, or the include here. Okay. Now it's nothing more. I think the build is probably finished, nearly finished. It's not quite finished. So we can just check here. Now we have Linux kernel header files like Linux, for example. We also have all the headers we need. Okay, you can see I made a lot of stupid mistakes before because I just make a lot of mistakes. So please check carefully when we are doing the thing here, right? Of course, you can see I'm just using a build system, but if you want to use a build system, I suggest you should do it after many times, right? You know what you're doing, then you can try that. Okay. Now we make install script. Okay. Now start build GCC. So build GCC, we do exactly as what we did before, but we need to modify the thing here, right? VS Code. Doesn't matter. We don't care about that. We need to put that prefix to somewhere else. Okay. Now you should be able to install the thing here, but we need to change prefix, change the prefix to here. Okay. I think it's probably more scientific than what I did before, just putting cross whatever. It doesn't matter, right? It just all math, right? So with G plus GXX, so here it needs to put here, but here it only needs one layer. Then we also need to put host. Okay. Host is x86 64 in Gdbc. Directory is 1, 2. See what layers 1, 2, 3, 4. It should work, right? GDC. What? GDC. Right. I'm going to echo it. Okay, I'm going to echo it. So just make all GC. No, just make J. Directly make J. I'm going to not using moments, right? Make J6. Okay. Deleted video. Why? Why the video is deleted? I think it's not deleted video. It's just not processed very well, right? Just it's not processed very well. It's still in the Canadian compile. Linux native compiler. aarch64. aarch64. What is aarch64 and ARM64? I actually don't know. aarch64. Nobody cares, right? Nobody cares about the thing here. CFG loop mandate. So If you have any comments saying you want me to show how to do RISC-V, you can tell me. Okay. Same thing. If you know how to do x86 and ARM64, I've shown that times and times again. You know how to do anything, right? The thing I'm probably gonna show is how to do DOS. How to do DOS. I've already made a video before. How to do new div. How to do bare metal. That's probably something which is new. This is wasting time, right? It's wasting everyone's time because. Right. The next video we're gonna just start to targeting LLVM to see how to do Canadian compilation with LLVM. I'm gonna have a first video on how to do native compilation with LLVM. From native, then we go to Canadian. But we first need to do native one. Six threads. It's just quite slow, right? I hope you just go. Someone is complaining just killing their process, right? G++. I'm just starting 6 threads. It should not. Wow. G++9. Why is G++9? Oh, it's NVIDIA CC. Okay. Python, right? Just the word of Python. What is Python word, right? Just everything is Python. See, probably the first video is it's quite difficult for a lot of people. Okay, particularly G++, producing a G++ algorithm. See whether today we have any with LLVM. Every time I do that, it's just gonna change the web assembly, Now I get to do it again and just here, okay, just doesn't matter, just do something here. They do a lot of changes. They just randomly change every day. Right? I want to see what change they're making here. Okay, next week we're going to just start targeting LLVM. Okay, it doesn't matter. Okay, it just forces you to use leave C++. This is quite ridiculous. I'm going to just using what I care about is only WebAssembly in the LLVM. I don't care about anything else. I really hope just targeting LLVM, right? Just targeting this in here. WebAssembly. Right, just add things. Triplet. EM scripting. It's exception handling. There's no exception handling, dude. Don't tell me you have exception handling in LLVM. They just don't have exception handling, right? You just, I don't understand why people want fucking exception handling. I'm gonna just wait for that. And I'm gonna test it. Just stop, right? Just wait and wait. If you just do it previous, right, with all issues, you should not have any issues in this step, right? All the bugs are fixed. We have all the problems we have fixed. right? Many, whatever. Just basically machines issues. We're gonna just try to see what's wrong with LVM. If it's forcing you to use right, this is ridiculous, right? You not use libstdc password. You're not allowed to do it, right? libstdc password. We're gonna go back to here. We're gonna go to the. Let me just see whether what diff I have here. No, I didn't do that. First, you need us to add virtual file system. Yeah. Okay, here's go here. Go here. Clan. Okay, you don't need to do that. Just basically just I need to use for Linux for using WebAssembly. I always have to do that with GCC with libstdc. I don't want to use fucking libc. It's just fucking bad, right? Just fucking bad. libc++ is a crap. It's absolute crap. This is what Apple is a crap, right? You're just getting 10 times, 20 times, you're 50 times slow down always using libc++. Okay. It's just no reason. I find that people just want to use that shit, right? There's just no reason to use that shit. Just use libc++, you're done, right? You don't need libstdc, libc++, okay? We don't care about that, okay? We don't care about that bullshit. I'll just copy this file to here, copy it. Now, another thing we need to change is how the search directory, right? How the search directory and searching the directory, whatever, cxx. Include, it doesn't search the correct include here. So we're gonna just change it. Alright, gonna change the thing here. I don't care about it. This ABC add is just very bad. You know, when you add things together, it will just be very bad. Okay. Yeah, just those things. I think that's enough. No more, right? No more. Don't care. What a client format, we can just client format or whatever. ASAN. Oh, it's already ASAN, right? Wow, it's quite fast. You know, it's faster than I thought. You know, this is ASAN, right? Anytime we see that, we know we're finished. We're nearly finished. are finished. Okay, we're finished. Go back to torchins, right? Torchins, GNU. Oh, not here. Yeah, okay, don't care. Nothing else. So we have an entire torchin here. Okay. Threads, Gdbc, and everything else, right? It's like C++ and library. Yeah, we have this 12, right? So we go back to Canadian, torchins. Go GNU, we're gonna tar CVF on tar aarch64, 64 GNU. Okay, 3 megabytes. Okay, we're gonna remember again to do what? Yeah, exactly. To do run administrator. We copy this. We go back to the torchins I have here. I'm probably gonna clean Windows up too in the future. Okay, I have the previous installer. I need to update it. Just remove the old installation. Not muscle libc. Sometimes it's muscle. Yeah, we always call it muscle libc. Even using muscle is basically the same, but muscle cannot do multi-lib. You need to disable multi-lib. Okay, we have the same issues again. Right, we're gonna auto rename it. Okay, so we go here, and we go net. We just rename it, and also set things to environmental variable to the aarch64. We have already set it right here. Don't forget to do that. Then we go to net IPv4, right? It should be Linux net filter IPv4. Here is the reason. Here's a problem here, right? Here's a problem. Okay, this is actually two header, They're actually two header. But it's called one. Okay, it's called one because it's renamed as one. It's just quite funny with entire thing here, right? You just have these all sorts of craziness with this bullshit, right? So we don't care. We don't care about the shit. Probably some people are gonna detect micro, just define them together. Just put those two files together, and we delete the file, delete it with ECN. We get another file, TTL, LP TTL. Right. Actually, if you do that, right, you think of it, with header guard, it will actually conflict with each other, right? Just quite shared, right? Just quite shared. Entire Linux kernel bullshit. Just kernel. It's a very bad kernel. Right. Now we're done. We have solved all these similar issues with these two headers. Now we're gonna start to compile programs to see whether it will work on our Raspberry Pi. Compile my library, for example. Compile a hello world, something like that. It's the problem with Git. It's just Git will just keep treating things, right? Or it's a problem with Windows Defender. Either Git or Windows Defender. Let's just see. I think probably Windows Defender. But they contribute both of the issues. Windows Defender. we get Android ADE, no.